We learned in the ball rolling down the incline lab that we can't model everything as a particle. Sometimes we have to look at an extended body. And so that's kind of what we're dealing with here is an extended body. This meter stick kind of wants to rotate a little bit, but if I get everything balanced perfectly, it won't. And that's because of not only the forces, but where on the stick they're acting. And so this is everybody's favorite thing from calculus that you haven't learned yet, the vector cross product. Here's what it looks like symbolically, and you're just like, oh, multiplication. Yeah, I think we learned that before calculus. Thanks, Mr. Harding. But it's a special kind of multiplication that involves three-dimensional vectors, okay? And so I've got the F, which you're not going to be too surprised by, is an arrow right here, okay? This vector is pointing straight down. Its magnitude is going to be, well, 0.268. That's not how you write 0.268. 0.268 kilograms times 9.8 newtons per kilogram. Who's got a calculator? 2.6 newtons. All right, cool. Close enough. Yeah. Okay. Now, the other thing that I'm interested in is where this force acts relative to the pivot. The pivot is right here at the 50 centimeter mark. That's the point about which it's going to rotate. So I'm going to draw a position vector from the pivot to the point of action for the force. That's what R hat is, okay? This is important. You'll see there's a few of these things, okay? But that means a specific type of multiplication in physics. That's called a cross product. In the last unit, we talked about dot products with the change in energy with work. And a dot product wants to know how parallel are these arrows. Cross product wants to know how perpendicular are these arrows. Okay, so we got to know about theta as well. So this is asking how perpendicular are these arrows? Hey, Sean, how perpendicular are these arrows? They're very perpendicular, okay? So algebraically, what's going to go into my calculator here is I'm going to take 2.6 newtons. I'm going to write it in a different order. I'm going to take the position vector, which is 0.5 meters. I'm going to take that times 2.6 newtons. I'm going to take that times the sine of 90 degrees, okay? Who's got a calculator? Don't need one. Whoa, bro. Mr. Harding's middle math skills are really impressive today. 1.3 meter newtons, okay? Who ever seen that unit before? No. Okay, it's all good. It's meter newtons. It's completely different from newton meters. So just don't even think about it, Sean. All right, so meter newtons of torque, 1.3. Positive or negative here, kids? So this is where the right-hand rule comes into play, all right? And to apply this right-hand rule, I'm going to start at the pivot, and my fingers are going to point in the direction of the position vector. They're going to fold in the direction of the force, and my thumb is pointing in the direction of the torque. So this is what I was talking about with 3 dimensions. And that's kind of dumb because, like, what? It's not rotating that way, Mr. Harding. Well, it kind of is if you think about how angular velocity works. Oh, okay, but spoiler. All right, so anyways, pivot, fingers point in the direction of the position vector. They fold in the direction of the force. My thumb's pointing out of the plane. Conventionally, things that are pointing out of the plane are considered positive, okay? But setting your pen down and forgetting where you put it, that's negative. There we go. So this is a positive 1.3 meter newtons of torque. Now, look at those dogs outside. What are they doing? Gross. Okay. If you look at the stick, based on what it's doing, what must be true of the total torque if you add all the torques together, all right? That doesn't mean a whole lot to you guys. It should mean a lot to the people that were here yesterday. So that's what I need you to be inputting over on the pair deck. So let me put you on the number slide. Number, all right? So yeah, put in a number value. What is the total torque? Don't look at it, Eddie.
I wasn't looking at it. I was,
Save your telekinesis for good, man.
I was sleeping with my eyes open.
Okay, cool. Number something. What do you think the numerical value of the total torque is? All right. Looks like some folks were paying attention yesterday. 0, 0, 0, 0, 0. Okay, so this kind of works like when you're summing forces and you get them balanced, your change in velocity is 0. Your acceleration is 0, right? Well, the rotational equivalent there is if these torques balance, then our change in rotation is 0. All right, cool. So let's talk about this a little bit more then. All right. I got a question for you. If I were to take a saw and cut this thing at the 50 centimeter mark there, cut, okay? How would the mass of everything on the left compare to the mass of everything on the right, okay? Greater than, equal to, less than, however that works. Cheers. All right. So if I cut it right there, right? If I had a saw and I just walked right over there and I cut it at the 50 centimeter mark and I put everything to the left of the 50 centimeter mark on a balance and then I put everything to the right of the 50 centimeter mark on a balance, what would I find there regarding the mass? Let me put you on a writing slide. Come on, man. Write something. Oh, nope, you already wrote. Boop. All right, writing slide. How would the masses compare? Mass on the left greater than mass on the right? Mass on the left equal to mass on the right? Mass on the left. Okay. Left greater than right, less than, ML greater than Mr. It depends. Mass is less because distance from pivot is greater, mass on the left greater, mass on the right, left greater than right. So generally speaking, it seems like people think the mass on the left is greater than the mass on the right. All right. Put your money where your big old mouths are. Slightly different question. I'm not asking you the mass of everything on the left. I want to know, what is the mass of the stick based on the information you have here? Don't worry about it, young. Maybe you do.
So if that is one, then you can just take a test.
If you want to be exact, be exact. If you want to just ballpark it, ballpark it.
Or only right now. We have one right from Utah.
I only got 4 people. Come on. If you don't want to give an exact number, give it like relative to 268. Like ballpark. How do you think it compares to 268? Such and such fraction of 268 or something, right? Sweet. Now I have 3 answers. So mass of all that stuff is 268 grams. So I want the mass of the stick, yeah, based on the information you got there. And now I have fewer answers than I had when I pestered you. Awesome. Let's look at what those answers are. 536 grams, 0.119 grams, 0.119 grams, 89 grams, 119 grams. Okay. You're giving me a seizure. All right, so clearly there's not a consensus on how that works. And that's good because we're just learning this stuff, okay? So my hope is that through completing the activity today, you will know what the mass of the stick is, and then we'll check it out, okay? So hopefully if you were here yesterday, you're through-ish the first 2 parts. When you get down to the bottom, your setup is different than mine. In your setup, you will have things hanging on the left and the right, okay? Have at it. Feel blocky today? Oh, is it sock? There you go, Kip.
They're playing here.
Oh, they're playing pool. Oh, never mind. I thought they were playing like Cedar Falls.
They play Cedar Falls, but it's not.
Oh my God, Cedar Falls for symphonic strings, and then gotta drive back down here and play Cedar Falls in soccer. That's what you knew it was something stupid like that. What?
You know what you just gonna use visual extras.
I guess.
What is it that
We're gonna dip it.
Okay, so we got one.
We look for the halfway for it too.
Yeah.
Once. You said halfway there.
Yeah. So the total on the left was positive. On the right was negative. Okay, so this is 23%.
Yeah. Okay.
We had it from the high. Yeah. We had it at like 5 and then I got them down. 23.
That's neat.
What up?
Is this supposed to like not pay?
Hopefully.
You might have to set it somewhere other than the TV because you know like stay like like set it so that it's down.
So, alright,
What?
what's the position vector?
Arrow that represents where a thing is relative to some reference point. The reference point is the finish. So if you look at the illustration up front,
It's oh, okay. Oh, so kind of like there.
so are you into the last part? So you should know how much torque, right? You know what to do to stick, right? You know the mass is fixed, figure out what the force is. And then I want you to identify where do I treat that force as being located.
We have to account for the mass of the stick that's on
Simplify. Mass and stick. Figure out the gravitational force that acts on the stick. You know how much torque is in this.
That's gonna be
Find the position vector.
Reps more
It'll make
things.
Figure it out.
our mass. So what if we're gonna say here? So that side is. This is that. Force down is what it looks like.
Yeah, my question. What little piece of
Right. Yeah. So that's the difference.
Oh, right, like super big inside.
Bro, here's my general science lab.
Okay, what's it at? Those figures?
So, another mass is
From that, that's it.
Not giving anything close to that. So,
Is 140 grams the weight of the whole stick?
yes. So, type divided.
Wait, so that was.
Yeah.
That gives me
That number?
twice. So I'm thinking, one of the numbers is 2. Either we should use, we should use an active type 6%.
That doesn't matter.
Because it's a front, it's not like localized, it's like still.
Okay, so then that's the force of it is, so we have the.
Well,
Yeah, because that one's only on that one side. And I suppose what we could do is calculate the total on either side.
That one,
it's like
that one was the one for you.
negative.
So we.
Yeah.
Yeah.
the profit's not in.
And then
That would make it.
Well,
So continue, plus,
You
these
have the
are,
next word on the side of it. That,
okay, so 100 grams is,
so it's grams. All we have left to deal with is either
that.
R long and or 0.1 kilogram.
Okay, so it's like that.
I think it's gonna be 1 pound.
Well, I think I
Maybe
could
we
review
could
it like,
just see if
sure,
we find something else.
Okay. Actually, probably like this is like multiple spread out. So what if we place, sure? So maybe the,
So that's how many babies are on that side.
And you need to add
so the other thing down there.
I already added that to it, and this side I haven't even started yet. So on this side is, yeah,
That give us.
and that's who that number is. Now we need to find the third.
So I'm thinking, I guess the red is.
You have to go take it.
Yeah, because like it isn't all looked like that. It doesn't have to be.
Wait, were we supposed to put R here? Or just on this side? Okay. So that's what we got.
No Dylan today?
So, this side. That's not right. Oh no, that is right.
Is this the same stick that we made?
For weight?
Yeah. That's not important.
Okay, so now we need to account for the missing.
Well, good. I got this.
I would figure it
That many.
Back here.
That's how much torque you're completely missing. It's just in the thing.
It's just, yeah. So, yeah.
Yeah, I didn't check it out.
So, more big stroke and physics here,
Imagine if like it's bound to like down and we have 50 because.
Okay.
Grab two. Grab two.
Oh no, I'm thinking about how like.
It's
It's like.
okay. So that's
That's
how much torque we're missing. And how do we find that torque then?
how many people?
What things? But no, we're supposed to have.
Right. It's having
Yes,
disproportionate, so.
because it's a massive stick out here. is what we're trying to do.
Yeah, we can, it has to go
So we
half.
have the number that we but we don't
So I'm
know
guessing we're gonna have to put that.
which 2 fingers where it's supposed to be going down.
The whole comes back to 25.
And
The other side, so 25. That's
The balance is 56. So your left distance is the difference from the center to the, wherever you put the weight. The force is whatever's going down. And the torque is multiplied.
okay, great.
Oh.
Equals something meters.
You got the center.
And
well,
then we.
If you want to redo the thing, just write down all the new information.
oh no, I just meant like this last part. Because that,
So it's supposed to be the.
yeah, that might be the, I'm just ready for
The max
like.
is.
I guess.
Because we need to.
What's up?
Especially because it's the third standard.
We can draw a graph by all means.
Right.
Here, draw a graph.
I'm really doing.
Okay, you need two forces, left and right, and then.
Two forces. One on the left, one on the right.
Yeah.
I was just showing
And against this.
Nothing's
yeah, but if you go further out, it's going to have more.
I'm looking at the actual math to see if that does anything.
Yours now. I knew.
So great. We could do it. I like to take some of that.
Could you give us a pointer? Because we're just kind of
What do you
our
got?
head against the wall. So we know the missing number that we need.
You got torque here. The torque here. This is different.
Yes,
What's responsible at causing that torque?
the mass. I don't know where to put. Okay,
The mass of,
the stick heads.
how much is the mass of the stick?
Oh, I think we decided.
Yes. Go mass the stick. It's on the sheet. It says mass the stick.
Oh.
I thought you were opening mass the stick.
But we gotta take all the little sticky things off.
That, minus,
With the mass of your stick.
In other words, we're big.
Everything's going on.
Hey, where'd that thing go?
No, well, I need to get past all those weird bad extra.
I like Thursdays because Thursdays are followed by Fridays.
Yeah,
probably. Oh, Eddie, I gotta show you this. I've been bragging up.
Some weak
Our girl. I don't know if you know this side of her.
oh, okay.
Sorry, it's like hella zoomed out. So I didn't have to remember. So here's the key for the. Yeah. She just sauced that girl with the sauce. So you'll have to tell her that sauce. So it's a gift for the loop, but yeah, she takes the girl on the dribble and just cuts to the left, and the girl just falls over. That's sauce. Like it got the full on. It got the full on. Crowd. So. Not a very Aeronoki thing to do, but she did it. So
I'll tell her
quality
white sauce next time.
Yeah, I don't know if she's working much right now, but
I think she works up one day.
there you
We
go.
have
So if you see her, hey, nice sauce.
50,
Way to sauce that girl,
90,
I think is how the soccer kids say it.
140, 150.
I don't think
This one is at
scales to get to the right place.
25,
Sweet
25.
donkey.
It is at 8,
You get